Hello, boys and girls. Welcome to Eureka Math, Module 1, Lesson 25. This is Miss Moreno. Today's lesson, Lesson 25, we're going to be looking at a fraction as a percent. Here is our learning target. I will write a fraction and a decimal as a percent of a whole quantity and write a percent of a whole quantity as a fraction or decimal. So let's take a look at example 1. Sam says 50% of the vehicles are cars. Give 3 different reasons or models that prove or disprove Sam's statement. Models can include tape diagrams, 10 by 10 grids, double number lines, tables, etc. So Sam is saying 50% of the vehicles are cars. And we need to give 3 different reasons or models that prove or disprove Sam's statement. So I see 1, 2, 3 cars out of 5, right? 4, 5. So 3 out of 5 of the vehicles are cars. 3 out of 5 are cars. Now, I know 5 is my whole number, so 5 would be equal to 100, right? Because we're looking at percent. So, to get 100, I have to multiply 5 by 20. 20 is my constant number. So, if 20 is my constant number, I also need to multiply 3 by 20, and that gives me 60. So, that means 60% of the vehicles are cars. So, I just disproved Sam's statement. He says 50% of the vehicles are cars, but my evidence shows that 60% of the vehicles are cars. I'm not done because I need to show you 3 ways, right? So that's one way. Here's another way. I'm going to show you another way by doing a double number line. So we always want to start by labeling the number lines. So vehicles, and we're looking at percents. So since there are 5 vehicles, I increase by 5. And 5 vehicles is 100% of the vehicles. Now, I need to count all the parts, right? So, let's count them. 1, 2, 3, 4, 5. So, I need to do 100 divided by 5. And I can conclude that the bottom double number line is increasing by 20%. So, let's go ahead and fill that in. 20, 40, 60, 80. Okay. Now I need to go to 3 cars. And I just proved that 3 cars is 60% of the vehicles. And I need to show you one more way to disprove Sam's statement. So here I have a tape diagram. I know that the tape diagram equals 100% because I partitioned it into 5 equal parts, and there are a total of 5 vehicles. So if I have 100 divided by 5 is 20. That means each unit has a value of 20. I also know that 3 of the units represent cars, and if you shade them in, the shaded area has a value of 60. So, we disproved Sam's statement. He says 50% of the vehicles are cars, and we proved 3 different ways that 60% of the vehicles are cars. So, how is the fraction of cars related to the percent? We started with 3/5, but we showed that 3/5 is equal to or equivalent to 60 over 100. 60 over 100. That means the percent and the fraction are both out of 100. The next section, use a model to prove that the fraction and percent are equivalent. We just did that. What other fractions or decimals also represent 60%? Here are some equivalent fractions that equal 60%. Okay, example 2. A survey was taken that asked participants whether or not they were happy with their job. An overall score was given. 300 of the participants were unhappy, while 700 of the participants were happy with their job. Given a part-to-whole fraction for comparing happy participants to the whole, then write a part-to-whole fraction of the unhappy participants to the whole. What percent were happy with their job and what percent were unhappy? So I'm going to start by focusing on the part-to-whole, comparing the happy. So I know that 700 participants were happy, and 700 is the part. To get the total, I need to add 300 plus 700, which gives me 1,000. So 700 out of 1,000 participants were happy with their job. That equals 70%. Now I need to answer the number of unhappy participants. Well, I know that 300 of the participants are unhappy, and that's 300 out of 1,000, and the percent is 30%. I'm now going to create a model to show you. So again, I'm using the double number line here. And you always want to label everything on your number line. So number of participants and the percent. So I have a total of 1,000 participants. So I need to make sense here. I would not increase by 1 because I would draw 1,000 lines. Even if I went up by 10, that's still too much. I'm going to go up by 100 till I reach 1,000. So we always start with 0, and I'm going to go up by hundreds all the way to 1,000. I also know that 1,000 participants is 100% of the participants because it's all of them. So it's 100%. Now I'm going to take this information here to figure out the percent. So I need to count the number of units, right? And I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm going to divide 100 by 10. So that means my percent is increasing by 10%. And I should have labeled it percent. So it went up by percent. And now I have enough information to prove that the percents are correct. So I forgot to label that percent, and that's very important to distinguish. Okay, so I want to show that 700 participants equals 70%. So here is 700, and I'm proving that 700 equals 70%. Now over here, we want to prove that 300 equals 30%, right? 300 participants, so you can clearly see that 300 participants equals 30%. Okay, let's look at exercise 1. Renita claims that a score of 80% means that she has answered 4/5 of the problems correctly. She drew the following picture to support her claim. We need to answer, is Renita correct? Why or why not? She is correct, but why? So see right here, I have one group of 20, because if you were to count all the units here, every unit you have one line of 20, and then 2 rows of 20, 3 rows of 20, 4 rows of 20. So I know that we have 4 rows, right? 4 out of 5 rows are shaded. And each row has 20. So if I multiply 4 times 20, I get 80. 20 is my consistent number. So 5 times 20 is 100. So 80 over 100 is 80%. So yes, she is correct. A better way she could have made her picture is by grouping them by tens. It would be easier to see. Okay, exercise 2. Use a diagram to answer the following questions. So you're given this diagram. As you can see, the top increases by ones. The bottom increases by 20%. 80% is what fraction of the whole quantity? So I just need to find 80%. And I can clearly see that 80% is 4. See right there? But it's 4 out of 5. So I would write it as 4/5. 80% is 4/5 of the whole quantity. Now it's asking me 1/5 is what percent of the whole quantity? Well, I'm going to go to 1, right? 1 out of 5. And I can clearly see that 1/5 is 20% of the entire quantity. 50% is what fraction of the whole quantity? So I don't have 50% on my tape diagram, but I can easily find it. Right, 50% is right in the middle, right in between 40 and 60%. So I'm going to partition it right there, label that 50%, and that's right between 2 and 3, so that means it's 2.5. So 50% is what percent of the whole quantity? 50% is 2.5 out of 5. Now 1 is what percent of the whole quantity? Well, I'm looking at 5, right? So 5 out of 5 is 1. So 1 whole would be 100%. Okay, make sure you finish the rest of your lesson. If you need help, don't forget to ask questions. We will be reviewing the math in our chat today, in our video chat. But do make sure that you have done the work up to here so that when we do our video chat, we can pick up where we left off. Thank you.